Before understanding the model, let us understand what is a hypothesis. A hypothesis is basically an observation, usually based on the cause and an effect. It is the basic or fundamental idea that has not been tested. So, as the name is suggesting, a hypothesis is just an idea that explains something but not yet tested. Now, a hypothesis becomes a model as soon as it is tested and validated. So, after some testing has been done and it appears to be a valid observation, then the hypothesis becomes a model. Now, although there is some principal or fundamental differences between hypothesis and model I have just explained, however, from the developer's perspective or for this course perspective, we are going to use these two terminologies, hypothesis and models, almost interchangeably and almost synonymously. So basically, a model is a function of x, which is the input variable, that can successfully predict y, which is the output variable. And we call a model, sometimes we express the model with hx, as it is almost synonymous to say hypothesis of x in machine learning. Now, how can I build a model or hypothesis? There is a process that you need to follow in machine learning. The process is basically, let's say you have got the training data set, and then you have to pass that training data set through a learning algorithm. Or the other way, the learning algorithm is applied on the training data set. And as the output of the algorithm, you will get your model or your hypothesis hx in here. Now, as soon as you will get your model or hypothesis, then you can pass the new input feature, new input variables, a new input data over here, and you can get the output or the value of hx here. Now, a model or a hypothesis can take any type of shape. It can be as simple like a straight line as you can see in this green solid line, or it can be as complicated like this as you can see in this pink colored dashed lines. Not only that, it can take a form of a surface also. It does not need to be restricted in the form of one-dimensional lines. It can be a surface in three-dimensional space, or it can be even higher dimensional based on the dataset and based on the learning algorithms. Now, in here, as you can understand, here in the green dataset, the model, let's say our first model is expressed as y equals theta 0 plus theta 1 x, where theta 0 and theta 1 are some numbers, and this equation basically depicts a straight line. Whereas the dashed pink lines is a complicated line, and it may take the form like y equals theta 0 plus theta 1 x plus theta 2 x square plus several other function, let's say theta 3x cube or something else. So it can take some complicated form. Now, whatever the model is, we can plot the model like this, maybe in two-dimensional space, maybe in three-dimensional space, or in higher dimensional space also. After you can plot this model, now you are ready to predict the output for new inputs. For example, let's say this pink line I am taking as this pink dashed line I am taking as our model. So let's say you got a new input data over here. Let's call it as x new. So what you have to do, you can just plot a line here and get the intersection point in our model like this in this pink dashed line, and then just get the value of y over here. This y is basically the value of your prediction. So this is how for an x new using this dashed line pink model we can predict the value of y like in here.